Welcome, Hornets. In this video, we're going to be taking a look at the different types of Riemann sums that we have and how we get them. So we're going to start off by just starting from where we left off in our previous video, where we had two different graphs that we had looked at as our left and right Riemann sums. And each of these values had heights. And so I've taken the opportunity to start with the left Riemann sum and then go to the right Riemann sum. So here are the values put into a table of values for the graph we just saw. Now, if we're trying to find a left Riemann sum, we're always working with our gap. Now, this gap can be equal, it can be unequal. If it is equal, we can factor that common value out and just work with sums. And I'll show you that in this one. But you do have to be careful. You have to have common values. Now, once we have that gap already identified, we have two values that are forming that gap, a value at 1 and a value at 3. The left Riemann sum says to take the left value. So we're going to choose 5. We're going to write it down as 2 times 5. Then we're going to continue with 2 times 6. Once you get yourself going, continue 2 times 5. Notice we're taking the 5 here, 4 here, going all the way down, and we use every value except the last. So we're going to have a 4, 3, 4, 5, and 6. And because they all have the common 5, we can always factor it out and do 5 plus 6 plus 5 plus 4 plus 3 plus 4 plus 5 plus 6. Now, whichever way you do it, it won't matter. You should end up getting the exact same value, and that value is 76. Now, in order to do the right Riemann sum, we follow the same basic process. So we're starting off with our gap. And now we're choosing our right side value. Notice we're now going to avoid that first value and use all of the others. So the left Riemann sum uses the first but not the last. The right Riemann sum does not use the first but does use the last. So you now have 2 times 6, 2 times 5, 2 times 4, 2 times 3, 2 times 4, 2 times 5, 2 times 6, and 2 times 7. Since they all have a 2, you can factor out that 2 and gives you 6 plus 5 plus 4 plus 3 plus 4 plus 5 plus 6 plus 7. And either way, when you multiply and add, you should end up getting 80. So you end up with an 80 in both. Okay, so notice that's the left and the right Riemann sum. You find your gap, and between the two values that made the gap, you look at the y values and you choose the value on the left. And then you continue with that pattern all the way to the end. You should avoid using the last value in the table. When working with the right Riemann sum, you're following the same process, but you're now working with the value to the right. Now there are still two other Riemann sums that we have. And these Riemann sums are a trapezoidal Riemann sum and a midpoint Riemann sum. Now the midpoint Riemann sum works with the value between. So we're going to go ahead and I've changed our table so that I have enough. And you'll notice there has to be a midpoint that I can get to. Now we can do a midpoint formula with unequal values, in which case we would just go over and use whatever in between. Okay? Now, once we find our gap, so we have a gap of 6 here, and 6, and 6, we choose the value of the height of the midpoint. The height of the midpoint in each case. And this gives us a product of 6 times 61 plus 6 times 53 plus 6 times 42. Because they're all equal, I could have 6 times 61 plus 53 plus 42. And I'll leave that for you to find. When we're doing the trapezoid now works with the average of heights. So we're working with this 64 and 55 as a sum divided by 2. So we have our gap and the average of heights. 6 times 64 plus 55 divided by 2. Next gap was 6. Last gap was 6. 6, 55 plus 48 divided by 2. And we had 6 plus 48 plus 37 divided by 2. Now, there's a lot we can do here. Just as we saw in the previous one, we can factor out the 1/2 and the 6 to leave us with 3 times. 64 plus 2 55s plus 2 48s plus 37. Either way, we'll always get the same answer. So it's up to you how you simplify it or what you work with. Once again, it's always going to be with the trapezoid. Riemann sum, you want the average of the heights in the interval. Average. 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 Multiplied by the gap. When you're working with the midpoint Riemann sum, you're making sure that you have your gap. In the center of the gap is the midpoint. You want the height of that midpoint. Gap times height, gap times height, gap times height. Then we had our left and our right Riemann sum. The left Riemann sum uses the left value and the gap. The right Riemann sum uses the right value and the gap. So keep in mind that means the trapezoid is simply an average between the right and the left Riemann sums. Okie doke. That's our Riemann sums. We'll continue to talk about their order, what's greater than what, as we continue, and we'll look at the limit forms of direct integrations. Thank you very much. Hope that has helped. Be well, be safe, and be kind to each other. And remember, it's always easier to be mean. So please, take the higher road, be nice to each other. Bye-bye.